Welcome to large-scale multiplayer gaming with open source. My name is Mark Mandel. I'm a developer advocate for Google Cloud for Games. And we're here to talk about some multiplayer game stuff. Does that sound like fun? Yay! Awesome. Wow, you really are excited. This is fantastic. All right, great. So before we get started, I would love to know a bit more about all of you, just so I can get a sense of who you all are and what you all do, and we can tailor the content a little bit. So how many people here work in the games industry? Oh, a good number of you. Excellent. Awesome. How many of you work on multiplayer games? Cool. How many of you want to work in multiplayer games? Some of you. How many people were just like, games are cool, this sounds like fun? That's fine too. That's cool. All right. So we'll cover some foundational stuff, and we'll get deeper into some projects, and we'll talk about some interesting and fun things. So before we get started, though, I want to put some constraints on things a little bit. When we say the words multiplayer games, that can be a very broad and distributed set of games outside in the world. So I want to bring that in a little. So the types of multiplayer games that I want to talk about today are your very fast-paced, online, competitive multiplayer games. So we're talking your Overwatches, your Fortnites, your Apex Legends, your Rocket Leagues, those kinds of really fast-paced, latency-sensitive, online, real-time multiplayer games. Those are the types of games I want to talk about, because they have some particularly unique constraints and have some particularly unique problems that they need to have solved to work in a reliable fashion. So we're going to actually see this demo today. I actually use a FPS called Sonotic. Anyone here know Sonotic? A couple people? Awesome. It's an open source FPS. If anyone played like Unreal Tournament 2000 or any derivatives from there, you're probably quite familiar with how it works. It has capture the flag. It has a lot of the classic modes, all that kind of stuff. And we'll have a look at that later. But that's very much the vein of the type of multiplayer games that I want to be talking about today. So traditionally, how do these kind of games work? There are several models for how to do this, but I want to talk about one very particular one, commonly referred to as dedicated game servers, because it has become one of the most prevalent patterns that is used in especially AAA large-scale multiplayer games. So what does this look like? So you might have, say, a couple of players who are like, hey, I would like to play a game. So cool. They take their game clients, and they usually connect to some kind of matchmaking system. So this matchmaking system's job is to potentially take maybe hundreds of thousands of players, take them all in and say, OK, let's look at things like maybe their skill rating, maybe their social graph, maybe other aspects of their gameplay experience, and group them together into a single gameplay group that's going to be a good experience, right? Like, group me with people who are likewise in my skill level, so it's not an unbalanced match. Or if there are particular friends that I like playing with a lot, put them together because that's a really fun experience for me. And so this is a really interesting problem because you do have to process potentially thousands upon hundreds of thousands of players at once. But the idea being that, yeah, let's get a good gameplay experience happening between the players that we have available that are online and waiting to play a game. So once we've solved that hard problem, cool. We've grouped together our players. We've got a group. We then need to create a dedicated game server for them to play on. So this could be a whole talk into of itself, but essentially a dedicated game server is a full simulation of what happens inside your game, like where your players are, what they're doing. It's authoritative. It tells everything what it is that needs to do. So once we have our players together, we need to talk to some sort of dedicated game server manager system. And this system's job is potentially to talk to thousands upon thousands of machines that are distributed around the world, right? Because we need to have these machines close to our players because latency matters a lot. So we're going to talk to thousands of machines around the world and basically be like, OK, we need to spin up one of these dedicated game server processes, and therefore, like, which one has memory, which one has enough CPU, what's its latency metrics compared to where my players are, et cetera. Spin it up, and then turn around and be like, cool, it's spun up. Now we need an IPM port. Where is this thing located? So we have an IPM port for this dedicated game server. Send all that information way back up the pipe to those two players that are wanting to play a game. And then they can make a direct connection to that game server by the IPM port, so they can interact directly with that in-memory simulation as that player plays the game. So it's a lot of work. Usually speaking, a lot of this is bespoke. Most companies generally do this themselves. It's probably less than ideal. So the things I want to talk about today is very much, what if there was, oops, sorry, let me go back. What if there was some sort of open source standard for matchmaking, wherein you don't have to solve some of the hard problems around how do I process hundreds of thousands of players? Wouldn't that be kind of nice? By the same token, wouldn't it be really nice if there was some sort of open source standard for game server management, right? I don't really care about how to distribute this workload geographically and how do I process, like orchestrate these things going up and down. I just want to write my game servers. So that's what we're going to talk about today. Sound like fun? Good. Before we get started, hands up people here who know what Kubernetes is. A lot of you. Fantastic. Awesome. Both of the projects we're going to talk today are heavily based on Kubernetes. But I want to bring it up for three very important reasons. Now, if you're not familiar with Kubernetes, at a very core level, the way I like to explain it is a system for programmatically being able to run software across lots and lots of machines. Everything else on top of that is really just nice sugar. But it's open source, and you can run it anywhere. And this is super important, because when latency counts for multiplayer games, being able to put your infrastructure close to your player base, super, super important. So the projects I'm talking about today are open source, and they will run on Kubernetes, and you can run Kubernetes wherever it is you need to. So that means then if you want to run it on us, like GKE, awesome, love it, great. But if you have coverage, like maybe in particular areas of the world where you just happen to have a player base we don't cover so well, you can run it there on your own hardware, on another cloud. That's really, really important. By the same token, you want to run it in your own QA centers, you want to run it on your own machines, you can totally do that as well. Secondly, this is also really important, standing on the shoulders of giants. Obviously, many of you are familiar. Kubernetes has a huge number of developers working on it and a massive ecosystem surrounding it. So we can take advantage of all those tools as well. Finally, simplicity is really important too. Usually, I talk to a lot of customers, and usually when I talk to customers, they have one system for like their account management and their marketplace and their inventory and their player systems. And then when it comes to multiplayer or dedicated game servers, they have a completely different system. If we can solidify on like one base platform for all our systems across the board, that's a lot less ops knowledge, a lot less difference in tooling. Really, we can really just not have to contextually switch as we operate from one platform to another. Cool. Kubernetes gets me very excited. Fantastic. So let's get stuck into the couple of projects we want to talk about. So we're talking about matchmaking. Open Match is a project that came out, I want to say somewhere between 6 to 8 months ago. It's an open source matchmaking framework, and I want to emphasize the term framework here, that is built with flexibility, scalability, and extensibility. What does that mean? Basically, we want to solve the hard problems for matchmaking, but still allow you to provide your custom match logic in the way that makes sense for your game and your players. So horizontal scalability, that stuff shouldn't be a problem for you. Really just focusing on exactly the gameplay experience you want. That's the thing we care about. So we're very flexible. We allow you to provide attributes for your players as they come in and out, basically arbitrarily as you need. And custom match functions, essentially, if you can put it inside a Docker container, you can write a match function. So we don't restrict you in any way in terms of what language you want to write it in, what platform you write it in. As long as you can put it inside a container, you are good to go. And the big thing I think that gets me most excited about Open Match is really the way it works concurrently. What we've seen traditionally in matchmakers, quite often they hit certain scaling limits, and that was a problem we very much wanted to solve. And I'll show a demo in a little bit about this, but really what we want to be able to solve those hard problems of like, I have 100,000 players coming in. How do I concurrently process match functions over these things? We want to solve those problems for you and leave that kind of the more game-specific stuff to yourselves. So we'll have a look at that. So, if we can switch over to my demo screen, please. Wonderful, thank you so much. All right, so I have an empty Kubernetes cluster. As you can see, it's not entirely empty. I do have, there we go. If I get config maps. I do have the configuration for Open Match already installed. It's just the standard config map that you get with the example, but with debugging turned off. And I'm going to install Open Match. So those not familiar, nope, example, sorry. We're just going to install some YAML files. So I'm going to, Open Match uses Redis for its persistent data store. You can either use one in cluster, which we're going to do here, or you could also use something like memory store or any other managed Redis. Beautiful. And that's going to install a bunch of stuff, right? And that's really it. There's nothing much more else to it. There's a bunch of components inside Open Match that are configurable, and we can mix and match a few things. I'm not going to talk too much about it today, but those exist. Now, I'm going to copy paste here because these are big commands. And we're going to put some players inside Open Match. So what we're going to do here is basically put in 7 cycles of 10,000 game players, or 10,000 generated players for us. Take a little second for it to come up. Come on, run. So we're going to spin up 70,000 players and insert those inside our Open Match cluster. You know you want to work. The demo gods apparently love me today. Come on, you can do it. I believe in you. There we go. There we go. Took a second. There we go. Wonderful. OK, so this is generating 10,000 players. We'll see a few numbers of these. There we go. So there we go. Beautiful. Obviously, it hadn't downloaded the image for a while, so that was taking a little second. So that's now generating some players, right? So 70,000, not a bad number. Here we go, here we go, here we go. So while it's doing that, I'm going to grab the next command. So what we're going to do is we're actually going to run some matchmaking once this is done, so you can actually see the concurrency in action. All right, so we have 70,000 players. Beautiful. All right, give me bash. Lovely, and I'm going to steal this command because I can never remember how it goes. Wonderful. So what I'm going to do is, oops, that takes a second to come up sometimes. Let me run that again. There we go. That ran really quickly. So what we did there is we ran, let me scroll up. We ran a matchmaking function, just a really simple matchmaking function that we use inside, we have inside the example, and we ran it with a concurrency of 2, right? Just concurrency of 2. And what we're actually doing is we're looking for groups of 16 players. And so it's going to run through. It's splitting that up. That's actually really not the best wrapping there, but you can see that we're splitting it up into teams of 16, and then we have it splits it up into 4 pools, each of about 14,000 players. And unsurprisingly, this is pretty successful trying to find groups of 16 inside 14,000. We have quite a few to choose from. We can get, we have number of successes 4, 64 players matched, and we have a throughput of about 26 players per second, which is not a lot, but we can do better. So let's actually do the same thing, but let's bump that number up to a concurrency of 20. So this usually takes 10, 20 seconds. You'll start to see here it'll say insufficient players. That's because some of our players' pool sizes are less than 16, and that happens in some cases, and that's fine. But it's going to break apart all the players that we have, and this is configurable. You can kind of play with how things get broken apart, and then process a much larger number of players, allowing us to get much better throughput inside Open Match. There we go. All right, beautiful. So now we can see here we've actually matched about 4,200 players. A little better than the 64 odd we had before. Now we can get through a throughput of more like 168 players per second. So this is how we can start to distribute the workload of what happens inside Open Match to be able to get higher throughput. Without, we really didn't have to change anything inside our matching function. We just changed our concurrency, which means we get some much nicer throughput. Can we go back to slides, please? Awesome. All right. So this is a bit better, right? We didn't have to write our matchmaker. Instead, with this custom matchmaker, we've put in Open Match. We've used common open source things like Redis, which many of you are probably familiar with. And we're able to insert Kubernetes and install Open Match on top of our Kubernetes cluster as a custom appliance. And we're good to go. But that's great. We can still do the same thing we had before, where we have players connecting to dedicated game servers. But, whoops, I want that sign. There we go. But we still have this server manager, yeah? We still have this bespoke thing that it would be really nice if I didn't have to build, quite honestly. So this is where we get into Agones. So Agones is another open source project. It's built in collaboration with Ubisoft. And it is an open source project for hosting, scaling, and orchestrating dedicated game servers on top of Kubernetes. I'm sure that wasn't surprising at this point. I'm sure many of you were seeing that coming. It's been a really great collaboration between us and Ubisoft. I just want to highlight it. They've been able to bring their institutional knowledge about how to run dedicated game servers and large multiplayer games over to us, and we've been able to bring our knowledge of Kubernetes and open source, and it's just been really lovely. I have to be completely honest with you. So super delighted to be working with them on this. So let's look at how Agones works. Very similarly, right? If you have a dedicated game server and you can put it inside a container, you are pretty much good to go. Right? I assume we're all fairly familiar with Docker containers. That's something we're all familiar with. Awesome. There is a dedicated SDK that needs to be integrated in some way, shape, or form. That SDK tells us things like, hey, this game server is ready, whether it's healthy or not, access to configuration, things like that. But this is pretty easy to do. It's not an onerous task. We already support a variety of languages, including C++ and Node and Rust, but it is all gRPC and or REST-based. So the short answer is, if you have a game server in any language, we can support it. You'll be fine. Actually, the Unreal SDK will be coming out this afternoon once I put the release candidate out. So that'll be nice too. We have more stuff coming. Yeah. So, hands up people here who have written Kubernetes YAML files. Many of you. Cool. If you haven't, that's fine. It's like one of the declarative ways that you can tell things, tell Kubernetes to do stuff. Anything you see here in a YAML file, you can also do directly through the Kubernetes API as well. So once you install Agones, what it actually is doing is extending Kubernetes itself to provide it new nouns, basically new actions that it knows how to do things with natively. And this is like one of the really cool things about Kubernetes and standing on the shoulder of giants that gets me very, very excited. So once you install Agones, it understands what a game server is, and it understands game server lifecycles. And this is really important, because game servers are kind of special in that when you don't have players on game servers and you spin them up, if you delete game servers that don't have players on them, nobody seems to mind. But when you delete game servers that do have players on them, players seem to mind a lot. If they get their game shut down in the middle of their gameplay experience, they're not happy. They post things on Reddit. They tend to write things Steam reviews. It's just bad for everyone. So once we have this installed, suddenly Agones really does understand, oh, there are players on here. And we'll have a look at that a little bit later as well. So here we define a game server. We can give it a name, a referenceable name, or even have it create one for us. We can specify the port policies we want to have. Agones will manage dynamic port allocation, so we can do that direct connection we saw earlier. And then finally, we specify the container that we want our game server to be. For those of you who are more familiar with Kubernetes, you can run a full pod spec here as well. So if you want to run multiple containers or volume mounts or config maps or any of that cool stuff, you totally can. But we can do better than just individual game servers as well. We can do fleets of game servers. So traditionally speaking, what you probably want to do with your game servers is spin them up and have a warm set ready to go, waiting for players to come in. Game servers can take a little while to spin up, so you want to have those sitting there ready to go. So if people are familiar with pods and deployments, very similar, we have game servers and fleets. So fleets are just lots of game servers. We specify how many replicas we want, and then we specify a game server specification, and it's the job of the fleet to ensure that we have lots of these ready to go. That's really it. If one of them falls over, or maybe one of them ends, we make sure we have another one spun up, and it keeps them alive and healthy. So here we have the Sonotic game server here, and we have 2 replicas of it available. Now, this is the fun thing, and I think, again, something particular to game servers themselves. We don't have load balancers, right? So how do we get players to a game server and mark it as, hey, players are playing on this thing? So we have this concept of what we call allocation. So here I show it as a YAML file. You'll probably do it if you were implementing it programmatically through the Kubernetes API. But I say to Agones, hey, I would like to create me an allocation, please. Grab me a game server, in this particular instance, out of the Sonotic fleet, and mark it as allocated, and do it for me atomically, and do it for me safely. Right? That's an interesting and fun problem, right? Like other things could be happening to your servers, they could be coming up and down, but Agones solves that sort of infrastructure problem of saying, oh yeah, you've got like 10,000 game servers running in this cluster, awesome, here's one that's safe. right? And it's now marked as allocated, and so we know there are players on it. So why don't I show you that in action? Would that be kind of fun? Sweet. All right, can we switch back over to demo? We already have. Oh, you're all amazing. So first thing I'm going to do is install Agones. I'm going to use Helm. Helm's a package manager for Kubernetes. So if you've ever used anything like Yum or apt or Homebrew, very much in that vein. So I'm just going to install Agones. I like Helm. Helm's great. So it's going to take the Helm chart. It's going to install it. Boom. There we go. It was literally that easy, which is lovely. I can actually show you, get pods, namespace. We can now see that we have several components already just sitting there. These are just the parts of Agones. We actually really don't care about them too much. So let's run a Synotic fleet, like we just saw earlier, right? So I can apply -f example Synotic fleet.yaml. Boom. Okay, cool. So this creates a fleet. Now, what's really cool about extending Kubernetes as well is all the extensions go through the API all the way down to the tooling. So I can now say get fleets, and it can show me fleets. And we'll see things like, oh, cool, we have 2 desired, awesome, so we had before, and 2 of them are ready. We can also look at them slightly differently. We can also see get game server. Right? We can see we have 2 that are available and ready to go as well. That's awesome. But 2 game servers, boring. Let's get more. Let's scale our fleet. Also, I don't know if you noticed, but I get tab completion on here too. I love this. Say like 200 game servers. That's way more fun, right? Much better number. And we can look at this in a couple of different ways. So here we have a fleet, right? We currently have 200. They're going to start coming up to becoming ready. They spin up really quick. There we go, 57, looking great, lovely. If we come across to here, you can actually also start to see some of the metrics that we have available to us as well. This usually runs a little bit behind because it polls every 30 seconds. It'll pick up in a sec. But we can start seeing things like rate type, how many game servers we have, what state they're in, count per type. So all the sort of metrics that you need as well for running game servers at scale come bundled in with Agones. Similarly, you have similar things in Open Match, but these are the sort of things that you shouldn't have to care about as a game developer. This should just be stuff that you all need. How many game servers you're running is a standard metric we should all just have. This shouldn't be stuff that you have to build yourself. So we can see all sorts of stuff. And this is just one dashboard out of many dashboards that we have inside Agones. So we have a look over here. Okay, so this is actually the dashboard's running us slightly behind, but we can see we have 200 ready. That's amazing. So let's allocate. Let's do that. That'll be fun. Create -f examples Synotic game server allocation. So I would probably normally do this through an API, like I keep saying, but I'm going to do it through the YAML file because that's what we're used to using here. And I'm just going to write -o YAML so we can see the response when it finally finishes. So boom. Okay, so that's given us an allocated game server. There's a bunch of stuff up top. The bit I really care about here is this, right? State allocated, we have an IP, we have a port, we have a game server that's been given to us that's essentially sacrosanct. So let's play a game. Does that sound like fun? Let's move that over. Yeah, this is the fun bit. All right. Let's plug it. Let's see if I can type really small things in front of a live audience. 417889. Join. Beautiful black screen is actually good. All right, so this is going to connect to the game server that we basically, we spun up 200 of these entire cluster, then we allocated it, and it looked inside the cluster and was like, hey, let's spin up one of these, and then, there we go. I'm going to play on my trackpad. This is me playing Synotic on a cluster that's running US East or US West, one or the other. There are some players around here somewhere. Without fail, there we go. As soon as I play in front of a group of people, there's never anyone around. Oh, there we go. Ha! Yeah! The most important part of this whole talk, really. All right, cool. That was fun. But I actually want to show some other fun stuff off, too. So I'm going to do, let's do a couple more allocations, because I want to show off this is cool. So we have, we can see here that we have 3 game servers that are allocated, right? We essentially have three game servers that have people playing on it. So let's scale this down. We're like, actually, these game servers, we don't like it. There's something wrong with it, something like that. So let's just say replica 0. Like flip the table and just be like, we hate this thing now. So that's going to start scaling that down. But we're always going to see that those 3 allocated servers always stay there. This is what, like, Agones does a whole bunch of stuff, but this I think is like one of the core basic things that it understands is that while we might have a variety of these being shut down, we don't touch allocated game servers. Super, super important. We don't interrupt player playing a game. Don't ever do it. It's bad. Bad, 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 bad. So, lots and lots of fun. So that's, yeah, so if we actually run that again, there we go. So we still always will see those allocated game servers until the players finish playing their games, and those game servers self-shut down. Very important stuff. Cool. Can we go back to slides, please? Excellent. Wonderful. Okay, so things are always better with friends. So let's see if we can make this work together. So we do have stuff wherein we can make these talk to each other. So what we can do is we can install basically what we commonly refer to as a director, or basically glue code between Open Match and a game server scaler, which can be custom if you so desire, so that a matchmaker can take the things in Open Match, right? You run your custom match logic there. It can talk to Agones and be like, hey, I've got players, let's matchmake and make a game. And then that game server can be marked as allocated. Those players can then play that game and continue on and have a really good time. So, one slide, we're back to demo. Fun. So in cooking show parlance, here's one I prepared earlier. So I already have, oops, that's AL, not what I want is all. I already have Open Match installed. I have Agones installed. There's a bunch of stuff already in this cluster. But what we're going to do is we're going to create the fleet like we saw previously. So that's going to create a fleet for us of a really simple game server. It literally just takes a UDP packet with some text in it, and it spits out a log. That's like, I know Sonotic is like super exciting, but this is like just very simple for demonstrative purposes. And then what we're also going to do is we're going to install the director. Basically, this is the glue code that says, hey, this is how I want Open Match to talk to Agones to scale, to allocate game servers for me, basically in the way that makes sense for me. So cool, that's good to go. Lovely. I'm going to grab this from down here because it's also got, oh yes, there we go, beautiful. And then I'm going to write a little script here, and I'm going to make sure this is ready, beautiful. So this is going to do a couple of things. So we're going to work on a much smaller scale this time. We're just going to work with one player, just so we can see the flow all the way through. So here, this is just going to generate one player for us. Very simple, right? Nothing too complicated. But then we're going to spin up a, once we've got one player, Open Match in this instance is going to be like, oh, we only need one player for a game, so cool, we can match make them. We're going to hit enter, and it's going to go, cool, we have a player, awesome. We're going to go and tell Agones, hey, allocate me a game server. So this here, IP import of the game server that just got allocated to us from Agones. Awesome. Next, this little script is going to spin up a client. Lovely. So this is a little client. We can use it to send UDP messages to the allocated game server. So why don't we actually pop over to our other tab. We have a look at our game servers. You see we have we have 2 that's allocated. That's fun. Let me see which one is going on there. 7616. I just want to get the logs from the right one. 76. So it's this one. Beautiful. This may have been lying around from before. So kubectl logs -f simple UDP. Beautiful. All right, sweet. So we can see that that's running. Now let's send a little command. We'll say hello. Now I want you to ignore the error bit at the bottom because demos always fail the day before. But the bit that I care about is where it says hello, right? So I've got connectivity now, right? Like I essentially can play this game. I can send packets to it. In theory, it should be able to send them back, but we'll ignore that for now. But we can work that all the way through. So essentially, we've been able to do the full stack from going from matchmaking all the way through to allocation of game server and having a person play the game. Now we can quit this and see something else that's also kind of cool. So what's going to happen now is this little script is going to start just allocating game servers. It's basically going to keep adding players to the matchmaking queue. As it keeps doing that, it's going to keep going to Agones and saying, hey, can I have a game server? Now, one thing we haven't talked a bit about today is the auto-scaling capabilities of Agones. So here we have one of our fleet auto-scalers already set up for us, and we can see that as we add players, our allocated game servers goes back up to 6. The auto-scaler is starting to kick off, right? We've got this at a really low number, so you can see the numbers go really slowly. Otherwise, it zooms up really fast. But you can start to see the numbers start to rise as we have this set up to say, hey, can we have 2 ready game servers at any point in time? And so every 30 seconds, it's going to kick over and say, OK, cool. There we go. Let's add a number 2. And then we'll add some more matchmaking to it, and then we'll just keep on rotating through. So we have some nice functionality there for auto-scaling as well, which is super cool. Awesome. Can I go back to slides, please? Excellent. All right. So what does this mean? So just wrap this up with nice visual diagrams. So we've had the players. They want to play a game. And in this instance now, they're going to talk to Open Match. Right? We're going to have our custom match logic in there. Right? We're going to distribute that player load over lots and lots of machines. Right? We can do that for you, which is lovely. And you just worry about your custom match logic. From there, Open Match can talk directly through the Kubernetes API, right? Usually through a director or something similar that's hooked into Open Match to tell it how we want it to allocate game servers through Agones. Agones itself can then look at a fleet of game servers that are already pre-warmed and ready to go, pull one out atomically, and be like, all right, this one here, that's allocated, and hand that information all the way back up to the players who want to play a game. Then finally, those players can connect directly to that game server, as we saw here, and as we saw with the Sonotic demo, and continue to play that game. We didn't have to build a lot of bespoke stuff. We can work on an open standard, which means it can run anywhere. We can really just kind of stand on the shoulders of giants ourselves as game developers and take advantage of the tools that already exist and really focus on the gameplay state and the gameplay mechanics and those aspects that really matter inside our game. So there's a bunch more to both of these projects that we don't have time to talk about today. I know I've mentioned it a bunch, but I want to hammer it home anyway about working on cloud providers. It works across all cloud providers. Basically, all these projects work on vanilla Kubernetes. There's nothing special in any of those. Both projects have auto-scaling capabilities. We saw some of that inside Agones. There's some more as well. Agones works with the Kubernetes autoscaler. Open Match has similar auto-scaling capabilities as well. Both projects have local development tools. So if you don't want to split up an entire Kubernetes cluster locally, you're able to use some lightweight tooling to be able to access and interact with and develop with both of those projects as well. And as we saw briefly as well, both projects have metrics and dashboards. Right? Metrics is really important for those day 3, day 4 operations. So we want to make sure that the standard metrics that you all need to do those kind of roles come along with both of these projects as well. On top of that, both of these projects have pretty solid roadmaps. Agones is still technically alpha. We are slated to go 1.0 at some point this year. Yes, that is a broad statement. I'm very happy with broad statements. You'll see a lot of things coming. More performance improvements. We've already done a whole bunch of performance work, and we've made it drastically more performant than it was before. More metrics as well. We want to do more commercial engines. As I said, Unreal's coming, well, in the release candidate today. We're working on Unity soon. It's already on the 1.0 roadmap. How to sort out multi-cluster is also front of mind. You're probably going to want to run multiple little clusters around the world. So how you do multi-cluster orchestration and multi-cluster allocation is already in the works. And you can see some work in the current release candidate for that as well. Also, Windows hosting. Many game developers use Windows machines. People want Windows hosting. Thankfully, in Kubernetes 1.14, the GA support for Windows is there. We're just waiting for that to trickle down into cloud providers as well. So lots of good stuff in that. On top of that, Open Match also has a quite good roadmap coming up. They want to look at long-lived matching logic. So for example, if you just want to have a service that's running up and you consistently hit that so that you can consistently hit that endpoint to run your custom match logic. More metrics and dashboards there. Player and match tracing is a big thing, again, so you can trace what is happening with each individual player as they go through your system. And they also want to look to increase and develop their build chain for development tooling as well. I would be very remiss if I didn't mention it. If you want to try out Agones, it's currently running 0.8.1, so it's a couple of versions behind. But if you just want a simple getting started experience with Agones, you can go to the Google Cloud Marketplace now, click a couple of buttons, and get a cluster up and running, and you can take it for a spin. So it's super nice. Finally, before we wrap up everything, I definitely want to say both projects are very alive, very active, but we're always looking for more contributors, more people to provide feedback. So if you are interested, definitely get involved on Slack. Come hang out with us on GitHub, file bugs, send feature requests. We definitely are looking for a diverse set of opinions from a wide variety of people from the games industry to come help us make these projects the best they possibly can be. That is the power of open source. But before you run off as well, if you have any questions, I'll be around at the conference. If you go over into the demo area, Build and Scale for Google Cloud, you can come talk to us as well about both of these projects and see a demonstration as well. Finally, if you want to follow us on Twitter, I'm @Neurotic because I joined Twitter in 2006, and that's something you could do in 2006. But you can also follow the Agones project on Agones Dev. But you can also see Agones at agones.dev and openmatch.dev for more information. Finally, thank you so much for spending the last 40 minutes with me. I know your time is valuable, so I really appreciate it. And I hope you all have a wonderful I/O. Thank you so much.